Welcome to Train Signal. This video is about name resolution. In this video, we're going to learn what a host name is and what a NetBIOS name is. Then we'll take a look at how these host and NetBIOS names are resolved into IP addresses. Then I'm going to show you how to configure your clients to support this name resolution. We'll take a look at how to troubleshoot name resolution. And then we'll wrap things up by learning how to integrate host and NetBIOS name lookup together. So first of all, what are host and NetBIOS names? Well, a host name is a DNS name. We've talked a lot about DNS in the last couple videos. A host name is the common name portion of a fully qualified domain name. For example, if we had a computer with a fully qualified domain name, or simply FQDN, of server1.globalmantics.com, the host name is just server1. So we could say that the host name for a computer is the common name for that computer within its domain namespace. Now, a NetBIOS name is defined as a name used to identify resources in a NetBIOS network. What does that mean? Well, NetBIOS names do not provide capability for name resolution on the internet. So this would be only in a localized custom NetBIOS network that we really are using these. A NetBIOS name is simple, flat, and only 16 characters long. It has no hierarchy at all, which is why it doesn't allow for any type of support for the use on the internet. The user will only see the first 15 characters, or I should say up to the first 15 characters, of a NetBIOS name. Matter of fact, the example that we have here, I have it listed as just server 1. That's short of 15 characters because we're just not using them all. You might even hear people refer to NetBIOS names as being a 15-character name, but technically there is a 16th character. That 16th character, or byte as it's sometimes called, is hidden and is reserved for the purpose of representing a specific NetBIOS service that computer offers. Now in the example on the screen, I have 20, and I have it in brackets, and we'll take a look in an actual system in just a little bit, and this probably will make a little bit more sense. That 20 in the brackets is representing a specific NetBIOS service that server 1 is offering. Now, sometimes when you do look at a computer and you look at its NetBIOS names, and again, we'll see this in a minute, you'll see multiples of what looks like the same name. And the reason why is because that computer may be offering multiple services. So the first 15 characters, which we see, will be the same for every one of those multiple entries. And then the hidden 16th character will then be different, representing each of the services that computer offers. Now, before we go any further, I have to tell you, NetBIOS names are pretty much a thing of the past. See, because of the amazing growth and popularity of the internet, most of today's systems function primarily using host names. Windows Server 2008 supports the use of NetBIOS names primarily for something called backward compatibility, where we allow support for older systems and applications. Now, if we were to go back a decade when we were dealing with Windows NT 4.0 or even NT 3.5.1, NetBIOS names were quite prominent. Matter of fact, Microsoft was pushing NetBIOS heavily because it is very simple. But because it doesn't have any support for the internet, we don't see a whole lot of it anymore. Now, computer names, whether they are host or NetBIOS, are only used by us humans, or stupid humans, as I've referred to us in previous videos. See, computers communicate on a network using a logical network identifier, most commonly known to us as IP addresses. And as I've talked about before in previous videos, we stupid humans, we can't remember all the IP addresses. We can't remember computers by their IP addresses. So that's why we go ahead and use simple names that we can understand. Well, if we're going to use these names, then we have to have a way to resolve those names into IP addresses so the computers will know how to communicate with one another. Now, there are two primary ways of resolving these names. The old way was to do it statically with text files placed on each computer. Now, this wouldn't be very practical in today's busy networks, so now we have the ability to resolve these computer names dynamically. Now, the text files that we used to use were the host file for resolving host names and the lm host file for resolving NetBIOS names. Dynamically, we resolve host names with DNS servers, and we resolve NetBIOS names with Win servers. All right, you know what? Let me just go ahead and show you what this all looks like within the operating system. Let's pop over to a machine. For this demonstration, I'm going to go ahead and connect with New York member 1. Now let me go ahead and connect to that. This is a Windows Server 2008 computer which we had already set up as a DNS server in previous videos, and it is still a DNS server right now. We'll get into that in a little bit. But the reason I want to use this particular computer is because as a member server, it gives me the ability to demonstrate both the client and the server side of what we're taking a look at. So now that we're logged in, the first thing I want to show you is the hosts and the LM hosts files. So what I'm going to do is I'm going to click on Start, and then in the Start Search window, I need to put in the path for where these files are located, and they are located in a very specific location, and that location is system root, or on this machine, system root is C:\/Windows\system32, and then once we're in that path, we then go to the drivers folder, and then in the drivers folder, we go to the etc folder, and I'm going to go ahead and open up that folder. In this folder, before we start looking at these files, I want us to, if you're following along, I want you to do one other thing. Go up to the Tools menu and select Folder Options. Once in Folder Options, click on View. And then I want you to clear this checkbox that says Hide Extensions for Known File Types. And the reason why, let me go ahead and clear it and click OK. The reason why is because we need to make sure that these hosts and LM host files do not have any extension on them. Now you'll notice the LM host file does have an extension right now. It says .sam. And what that means is this is nothing more than a sample LM host file. There is no functioning LM host file on this computer right now, which is not unusual. Matter of fact, that is the default because we are not really using NetBIOS names. And even if we are, we're not using LM host files. That would be, we'd be going more than a decade into the past if we were doing that. But I want to show you this just because it's good to know in case you come across one. Let me go ahead and open up lmhost.sam. I'm going to double click on it. You'll see since it's a sample file, Windows doesn't know what to open it with. So I'm going to select a program. Okay. And we'll use Notepad. Now I'm going to clear this checkbox because we don't always necessarily want to use Notepad for all sample files. That's what that would do. That would turn all .sam files. It would just take that extension and associate it with Notepad. We don't want to do that. So clear that box and click OK. Now we're in a text document, and every one of these lines begins with the pound symbol. Okay, there's always this pound symbol right at the beginning, and that means that it's what's called a comment line, meaning none of this text that you see in here has any meaning. This is all just explaining how an LM host file works. Now, if I wanted to create a real entry, what I would do is go ahead and put the cursor down here and type in an IP address, put a few spaces, or some people hit tab. I've learned it really doesn't matter. And then I'll type in a name, just to give an example. This IP address, 192.168.10.201, happens to be the IP address of New York DC1. And this entry right here will now tell this system, when trying to look up the NetBIOS name, New York or NY-DC1-2K8, to go to that IP address. That's all there really is to an LM host file. Now, technically, there is a little bit more to it. If I scroll back up here, you'll see there are some additional extensions that you can put at the end of the line, pound pre, pound dom, etc., etc. And down here, there are even some examples of that where you put in the IP address, the name, and then a pound pre, or up here they show pound pre and pound dom. I'm not going to go into that kind of detail right now. The odds of you working with an LM host file are slim to none, but I just wanted to point that out in case you ever end up having to deal with one. The last thing I would have to do if I wanted this to be a functioning LM host file would be to click Save As and to get rid of the SAM extension. And another good thing to do besides getting rid of the extension is to change this file type from a text document, which means it's going to most likely attach the .txt extension to it. So just go ahead and save it as all files. And click Save. And I'll go ahead and close it. Oh, you'll notice it saved it as lmhost.txt anyway. So let's go ahead and just eliminate that extension. Yes, I want to change it. It's just warning me I've changed my extension. And now, right here, I have a functioning lmhost file. Now, what about the host file? Let's go into that. Here I have the host file with no extension. This is a functioning host file. Again, it wants to know what I'm going to open it with, and I'm going to select Notepad. And here, this is a real host file. Here again, we have all the comment lines. This is just examples. But then down here, we have two entries. We have 127.0.0.1 resolving to localhost. And then we have : :1 also resolving to localhost. And what those two entries are a couple of entries that will tell this computer that if anyone puts in the IPv4 address of 127.0.0.1, that points to localhost, which would be itself. And : :1 is the IPv6 address, also representing localhost. If I wanted to put in an additional host name that I wanted to resolve to, I could go ahead and I could put in, again, let's say 192.168.10.201, put a few spaces or a tab in, and I could now say that that resolves to ny-dc1-2k8.globomantics.com. That's all there is to a host file. Now, these files may be extremely simple to create, and the entries may be very simple to read, but here's the deal. If you're going to use hosts and lmhost files, every time you add a computer to a network, remove a computer from a network, change the IP address for a computer on a network, you would have to go to every single computer and update the hosts and or lmhost file. So let me go ahead and close this. Sure, we'll save it. That's a legitimate entry. And let's go ahead and close out of Explorer here. And let's take a look at the server side of things. Now, as I mentioned before, this computer is already a DNS server. We can see that by clicking on Start and going to Server Manager. In Server Manager, it'll take just a moment to open here. There we go. If I click on Roles, I'll expand them here. Again, taking just a moment, it wants to collect the data to figure out what role it has. Here we see it is a DNS server. And here it's pointing to itself, New York member 1. And this is where we can see that we have different zones that we learned about in the previous lessons. And inside those zones, we have entries pointing to, you'll notice we talked about A records or host records. Well, that's because a host named Ed is in the demo.local domain. Okay, so that's what we can do with DNS servers. We can have a database, and we can have clients point to this database to resolve that information. And to take it a step further, I talked about how this is the new dynamic way to do it. Well, first step we had was just DNS servers where we had to manually make all these entries. And that still saved a lot of time, because instead of having to go to a host file on every single computer every time there was a change, all I had to do was come here and make one simple change. But now we can take it a step further, and what I'm going to do is right click on demo.local and go to its properties, and you will see here that we have something called dynamic updates, which allows clients to dynamically communicate with the DNS server to basically, let me cancel out of here, say, hi, I'm Ed, and my IP address is, let me expand this so we can see it, 192.168.10.100. Okay, so that entry can be dynamically entered in, and if computer name Ed, or a computer with the host name of Ed, were to have its IP address changed, it could dynamically come to the DNS server and say, hey, I need you to update your records to say Ed is now, let's say, 192.168.10.150, if that's what my IP address became. So that's how a DNS server allows for dynamic name resolution. Or I should really say dynamic host name resolution. And the reason I want to put the emphasis on host name is because NetBIOS names are dynamically resolved through something called a Win server. Now, in Server 2008, let me go ahead and close this up and click on Roles. Over here, let's go ahead and click on Add Role. You will see here, there's the checkbox for DNS server. It's already installed. I should really say, instead of you'll see here, you will not see Win server as a role. Because NetBIOS is such a thing of the past, Microsoft has not even included a Win server as a role for Server 2008. So let's go ahead and hit cancel. Yes, I want to cancel out of the wizard. Okay. Wins is now considered a feature. So I'm going to click on Features and click on Add Features. And if I scroll all the way down to the bottom here, down to the W's, here you'll see Win server. So I could check the box and then click on Next. And it goes ahead and it gives me a basic confirmation of what I'm about to do. I'll click on Install. It now is going to, you'll notice it says the following role services or features. Okay, it's a feature this time. Feature of Win server is being installed. Now again, there's not a whole lot of detail that I want to get into right now about the Wins server, particularly because very, very minimal use of this particular feature in Server 2008. You would need to be in an environment that still has a lot of older applications and systems still running on it. So it is possible that you may run into it, but not a real strong chance. What I will tell you about the Win server feature is that Wins is also dynamic. Matter of fact, that's why Microsoft was pushing NetBIOS so heavily back in the days of Windows NT, is because they had implemented this Wins server, which was a dynamic way of allowing clients to go ahead and communicate with a server so that that server's database could be updated. That was back in the day when DNS could not be dynamically updated. So let me go ahead and click on Close, because we are now installed. And if I expand my features, well, I'll tell you what, since that's taking so long, let me go ahead and close that. Let's just click on Start, Administrative Tools, and we'll go down to Wins. We'll do it that way. Click on Wins, expand this. Here you'll see New York Member 1 is now a Win server. And I could go in here and look at active registrations, and you'll see there are none. And the reason there are none is because nobody is pointing to this particular server as a Win server. So we'll go ahead and come back and take a look at this briefly after we look at client configuration. But first I want to show you one other thing before we get into discussing that client configuration. Let me go ahead and minimize this. And I'm going to go ahead and open up a command prompt. So I'm going to click on Start and select Command Prompt. In the command prompt window, there are a couple of commands I want to show you. The first is called hostname. If I type in hostname and hit enter, you'll see that it displays my hostname, New York-Mem1-2K8. Not a surprise. Now, in order to display the NetBIOS name, wouldn't that be cool if I could just type that in? Yeah, it doesn't work. There is no such command as NetBIOS name. But what there is NBT stat. Now I'm going to go ahead and hit NBT stat and hit enter without anything first. And you'll see here that it shows me all the help for what I can do with NBT stat. The one line in particular that I want to show you is right here, -n or names, where it lists all the local NetBIOS names. This is a tool that you can use to view and manage NetBIOS names on either a local computer or a remote computer. So I'm going to go ahead and put in if I could type NBT stat -n for names and hit enter. And you'll see here that I get a list that shows me all the NetBIOS names on this particular computer. I have New York Member 1 2K8 00. You'll notice another one down here for New York Member 1 2K8 20. So those are two different NetBIOS services that this particular computer offers. And then we have Global Mantix, which is what's called a group NetBIOS name, meaning it participates in the Global Mantix group. So it is recognized as one of the Global Mantix computers. It's within that domain. Now, not to be confused with globalmantix.com. You'll notice there is no .com here. See, just as and New York member 1 2k8.globalmantics.com is simply known as New York member 1 2k8, well, globalmantics.com is just simply known as globalmantics. So anyway, that's how you can view your NetBIOS names and your host names. Let's go ahead and talk a little bit about client configuration. First of all, when it comes to client configuration, we've already looked at a small piece of this. We've looked at the host and the LM host file. Although we were on New York member 1, which is a server, that we were looking at it from a client point of view. Those files would not be placed on the server. They would be placed on each individual client, of which New York member 1 is. It's a client and a server. But that's the old static way of doing it, which we really don't do anymore. What I want to talk about here is how to configure a client for dynamic name resolution. Now, the first thing we do here on a client is we configure it with a DNS server list. And this is really nothing more than a list of DNS servers that client will go out and make queries to while trying to resolve host names to IP addresses. Now, there is no limit to the number of DNS servers that you can put on this list, but for all practical purposes, you want to keep it to a small handful. If we were to throw, let's say, 100 DNS servers on the list, by the time the client gets to that 100th server, the human who's sitting at that client has probably given up on waiting for that name to resolve anyway. So usually you keep it to a very, very small number, 1 or 2, occasionally a third or a fourth. Now, another thing that we have with our client configuration is we can enter in a DNS suffix search order. Now, this is what allows the end user to use the simple host name instead of the fully qualified domain names. It would not be a whole lot of fun if every time I wanted to get to server 1, if I had to type in server1.globalmantics.com. That would not be fun at all. So what we can do is we can enter in a suffix search for globalmantics.com. And what that means is any name that we look for will automatically apply that suffix of globalmantics.com. This will make a little more sense when we look at it in just a moment. Now, the other side of things, the NetBIOS side of things, we can configure the client with a Win server list. And this, again, is nothing more than a list of Win servers that the client will query when attempting to look up a NetBIOS name. The only comment I will make here is that there is technically a limit. A client can search for up to no more than 12 Win servers. Now, as I mentioned with the DNS servers, I'd be shocked if we ever even entered 12 servers. I've certainly never seen it. Matter of fact, I don't know that I've ever seen more than 2, maybe 3 Win servers in a system, and not for quite some time since NetBIOS is kind of a thing of the past. All right, so let's go over to a client and take a look at how we configure it. To demonstrate client configuration, I'm going to go ahead and connect this over here to New York Vista 1. We could still use New York member 1 because technically a member server is also a client, but let's go ahead and use a more common client operating system. So let's go ahead and connect to New York Vista 1 now. Okay, there we go. In order to look at the client configuration, we're going to look at the TCP/IP properties. So I'm going to click on Start. I'm going to put my cursor on Network and right-click and select Properties. This will open up the Network and Sharing Center. Once we're in here, I'm going to click on Manage Network Connections. And here we have our local area connection, which I will right-click and select Properties once again. Highlight TCP/IP version 4 and click on Properties. Okay, so here we are in our IP version 4 properties. Now, the first thing is right here, we see whether we want to obtain our IP address automatically or use a static IP address. Right now, we are dynamically receiving our IP addresses. Down here, we then get a choice to obtain DNS server addresses automatically or use the following DNS server addresses. And in this case, I am statically pointing to an IP address of a DNS server that I know is going to support our needs in this particular network. Now, this is one way to start off your DNS server list. You'll notice here we have the preferred DNS server, and I've got an IP address. I could then put in an alternate DNS server, and I could put in that IP address, 192.168.10.202, which happens to be the IP address of another DNS server. It's actually New York DC2 on our network. But let's get out of this window and let's click on Advanced. In Advanced, I'm going to take us over to the DNS tab. It's on this tab that we can enter our DNS server list. In the first screen, we could only enter 2 DNS servers. If we have more, then we have a list here. I could go ahead and click Add, and I could add the IP address of another DNS server, of which I don't have another IP address in particular, so I'll just make one up. We'll say 203, and click Add. And then now you see I have a list of 3 DNS servers. Over here, I have arrows, so maybe I don't want 203 at the bottom of the list. Maybe I want that one first on the list. The order is significant because that's the order that the client's going to go out there and check. So the client will go out there and say, hey, 192.168.10.203, do you know who, whatever name is? And if I don't get a response, then I go down to 201 and then I go down to 202. Now let me go ahead and highlight 203 and click remove because I know that that's not valid on our network and I don't want to mess things up here. But what I do want to take you to is right down here where it says the following 3 settings are applied to connection with TCP/IP enabled for resolution of unqualified names. See, unqualified, not fully qualified domain names. And here I check the button that says append primary and connection specific DNS suffixes. What that means is because my primary DNS suffix, meaning this particular computer is the member of the globalmantics.com domain, it will go ahead and append the globalmantics.com suffix automatically to any unqualified host name. Now, the checkbox right here is for appending parent suffixes to the primary DNS suffix. There is no parent suffix in this particular instance, but let's say, for example, let's say I was the member of the asia.globalmantics.com domain. Then the primary suffix that it's going to add is asia.globalmantics.com to all host names that I search for. And then the parent suffix that it would also search for would just simply be globalmantics.com, which is the parent to asia.globalmantics.com. Now, if I want to take this a step further, I could click this button down here that says append these DNS suffixes in order. And I could manually add DNS suffixes that I want to search for. This would come in very handy if we were working in let's say a multi-forest environment where we have many different domain structures that we may want to be searching for. So not as typical. The typical is to just go with the defaults, which is appending the primary and the parent. But we do have that capability if we want to add a specific DNS suffix list. Now, as long as I'm in this screen, I'm going to show you one other checkbox, which is very important, which is right here. Register this connection's address in DNS. It is this particular checkbox which very specifically allows us to communicate dynamically with a DNS server. It's that checkbox that makes it that this computer, New York Vista 1, when it turns on, will go to its DNS suffix list, or I should say, its DNS server list, and go out there and say, hey, DNS server, my name's New York Vista 1, and here's my IP address. Okay, so the checkbox to register this connection's address is what allows this particular client to participate in dynamic DNS. Now, the next thing I want to show you is the Wins tab. On the Wins tab, this is, primarily this right here. This is where I can put the list of Wins servers. I can go ahead and add the IP address. Let's go ahead and put in, I don't actually know the IP address for New York member 1. So let's just put in a hypothetical. We'll say 210. 192.168.10.210. I'll click Add. I'm now pointing to that particular Win server. Matter of fact, for the importance of showing you the Win server side, let me go ahead and take a look at what New York member 1 is. And watch this. I'm going to click on Start. And in the Start search, I'm going to type CMD, which would be to open up a command prompt window. In that command prompt window, I'll just simply ping New York mem1 2K8. And boom, it resolves. Aha, it's 192.168.10.100. Wonderful. So let's go ahead and edit this entry and point to 100 and click OK. And I'm going to click OK to get out of this window. Click OK again. Click Close. Close. And close. Whew. A lot of windows we had open there. All right. Now, the last thing I want to show you before we leave New York Vista 1 would be to click Start, go back to our command prompt, which we've just recently opened, so it's been added to our menu, and type in ipconfig/all and hit Enter. Now, the reason I want to do this is I want to show you, let me scroll up a little bit here. First of all, our IP address of 192.168.10.225. I want you to hang on to that IP address in your mind for just a moment. But first, let's look down here at our DNS server list, which is listed as 192.168.10.201 and 202, which we just configured a moment ago, and a primary Win server of 192.168.10.100, which we also just configured. All right, so we can see through our IP configuration that the client has been configured, but let me go ahead and minimize New York Vista 1 for just a moment. Let's go back over to New York Mem 1. On New York Member 1, let's bring back our WINS utility and go ahead and right click on Active Registrations, and I'm going to select Display Records. Now, I have the ability within the WINS utility to filter these records. I don't want to do any filtering though, so I'm just going to click Find Now. And it shows me all the records on this WINS server, and you'll notice a couple entries have been made for New York Vista 1. They point to 192.168.10.225, which is the IP address of New York Vista 1. You'll notice we have 00 and 20, which are the workstation service and the file server service. So those are the NetBIOS name records for New York Vista 1, and they have been successfully communicated with New York Member 1, which is our WIN server. So let's go ahead and minimize New York Member 1, and let's go ahead and connect to New York DC 1. Now, the reason I'm connecting to New York DC 1 is because that is the DNS server at 192.168.10.201, which the New York Vista 1 client is pointing to. So let's click on Start, Administrative Tools, and go to the DNS utility. In the DNS utility, let's expand our forward lookup zones and look at the globalmantics.com domain. In here, you will see there is an entry for New York Vista 1. Again, it's a host record with the IP address of 192.168.10.225, the IP address of that particular host. So, as you can see, the client has been configured properly to communicate with its WINS and DNS server, and we've looked at those servers to see that communication has taken place. So now, let's go take a look at how to troubleshoot name resolution. When it comes to troubleshooting name resolution, I have a pretty simple philosophy about how I go about it. I have this listed on the screen for you. It says, in order to troubleshoot name resolution, we need to understand the name resolution process and then find where there's been a breakdown in that process. Now, this may seem really obvious to you. If you've been to a troubleshooting class, you will have heard that this is troubleshooting 101 for pretty much anything. The reason I put it out there in this manner is because I have seen so many administrators go about troubleshooting name resolution the wrong way. So let's go ahead and look at the process, and then I'll talk to you a little bit more about some of the mistakes that are made. Okay, here I have the name resolution process, and you can see it's going to be a 6-step process. But let's start off with, we have a client here who's looking for the IP address of server 1. And of course, if the client has been configured to append DNS suffixes, and if this client was a member of the globalmantics.com domain, it's technically going to be looking for server1.globalmantics.com. But either way, the first thing this client is going to do, matter of fact, the very first step, technically there's 7 steps here. The very first step isn't even listed. The first step is it's going to look to say, is that me? Am I server 1? So assuming that the client is not server 1, well then step 1 is it's going to go ahead and look to its DNS server cache, the local cache, to see if this is maybe a host that it has looked up recently and it has stored in that cache. Now you'll notice in step 1 I've also included the host file. This is all listed as one step. And the reason why is because anything in that local host file is going to also be preloaded into the DNS cache. So you may find, if you've ever read any books on this or taken other classes, you may have seen that the DNS cache is listed as step 1 and the host file is listed as step 2. Technically, they are one and the same. If it does not find the answer to what the IP address for server 1 is in the local cache, then we go on to step 2, which is querying a DNS server or possibly a list of DNS servers which the client has been configured with. So step 2, client says, hey, DNS server, do you know who server1.globalmantics.com is? And if the DNS server has an answer, well, then it sends that answer back to the client. If the DNS server does not have an answer, then the client will go ahead and query its local NetBIOS cache. Now, this might seem kind of weird because we're looking up a host file. Well, these steps right here were all it had available to it to look up a host file. It looked in its local cache, it looked at the host file, it checked with the DNS server, doesn't get an answer. Well, rather than just giving up, what it will do is it will look to the NetBIOS name cache to see if there's a NetBIOS name for just simply server 1 that matches. And if it does, it'll accept that as an answer. If it does not, well, then it moves on to step 4, which is it will query a WINS server for a NetBIOS name for server 1. If it does not get an answer from the WINS server, it'll actually go out there and do a broadcast. It'll say, hey, everyone, I'm looking for server 1. Are you out there? And this is actually part of the NetBIOS name lookup process, but that is something that it will do. And if it still doesn't get an answer, the very last step is it will look at its local LM host file. Now, as I stated to you before, this is a file that is very rarely used, but on that off chance that it is used and there is an entry for server 1, it will check with that LM host file. At this point, if it does not find an answer, the user on that client is going to then get the error saying unknown name, host can't be found, etc., etc. So that is the complete 6-step really host name resolution process. And the reason I say host name resolution process is because if we were going to be looking up a NetBIOS name, then technically these are the 4 steps that we're going to go through first. So if it's a NetBIOS name, we're going to look at the NetBIOS cache, then the WINS server, then broadcast, then LM host file. And believe it or not, if we don't find an answer to a NetBIOS name lookup with those 4 steps, then we will go ahead and steps 5 and 6 would be looking in the DNS cache for a host file with a name similar to the NetBIOS name we're looking for, and then a DNS server. So these 2 steps are the host name lookup. These 4 steps are the NetBIOS name lookup. And all 6 steps are pretty much always done. It's just a matter of which are done first, whether the 2 are done first or the 4 are done first, based upon what is the primary name that you're trying to look up. And in a Server 2008 environment, we are typically looking up host names, which is why I've listed these 6 steps in this order. Now, this might seem obvious. It may seem simple, but believe it or not, there are some real common mistakes that administrators make. And let me give you the number 1 mistake that is made out there. And that is if a client says, I'm trying to find server 1. So client's trying to find server 1. And let's say it's being given back an answer, but the wrong IP address. The first thing almost all administrators will do is they will look to the DNS server. They'll go to the client, they'll do an IP config, they'll see what DNS server they're querying, and then they'll go to the DNS server and find out why they're getting the wrong IP address. That is a really common assumption, and the reason why is because the host file is not being used in most environments. Now, some administrators will go one step better, and the first thing they will do is they'll go to a command prompt and type in ipconfig/flush DNS, which is to flush the DNS cache. We'll go take a look at that in a minute here to make sure you know what I'm talking about here. But that is one step better to where they flushed out the DNS cache, meaning they're doing the right thing. They're looking to step one. But if that doesn't work, then they immediately jump over to the DNS server and don't see anything wrong and start scratching their heads trying to figure out why server one's being given, or the lookup for server one's being given the wrong IP address. The step that they're missing is this guy right here, that host file, because it's not used. And it is something that I have seen, and I've seen more often than you would believe, considering we don't use host files anymore. The reason that this happens, the two main reasons that I have found that the host file may have an invalid entry is, for one, you may be in an environment where you used to use a host file, but you don't anymore. So maybe you have a client, it's an older client, who had a host file from back in the day when host files were being used. You've more recently switched to using DNS servers, but the IP addresses of the significant servers on your network haven't changed. So what's happening is the client, although you think the client's getting the answer from the DNS server, that client has been always getting it from the host file. But there haven't been any problems because the IP address hasn't changed. Now, maybe you've had a change on server one. Server one has a new IP address. Client is still getting the old IP address from that host file, and that's where you're going, well, why? You're sitting there scratching your head saying, why? We've changed that IP address. And immediately, again, everyone jumps to the DNS server to say, why is that not being updated? Why? Where is that bad address coming from? So that's one reason that the host file may still get in the way, is if it was formerly used and now there was a change made. Another reason that you may find this is if I've found it is common when a network has been attacked. And sometimes it's not being attacked with one specific attacker, but maybe even spyware. It's not uncommon for spyware to go in and make false host file entries, which means when the client makes a request for a given host name, it gets that false IP address from the host file first. So that's just to give you an idea of some of the typical mistakes that are made by administrators by not going step by step through the name resolution process. So if you ever have an instance where a client is either not getting a host resolved that you believe it should be, or it's getting resolved but to the wrong IP address, make sure that you take very, very close caution at the concept of, well, step one is to look at the DNS cache. And if that seems wrong, it's not just a matter of flushing the cache, because if there's a host file entry, it's going to repopulate that cache right after you flush it. After you have checked both the cache and the host file, then you can move on to step 2, 3, 4, 5, and 6 to go ahead and figure out what is wrong with the name resolution process. Now, as I promised, let me go ahead and take you back over to a client machine so that we can look at the DNS cache and the host file. All right, so let's go ahead and connect back up with our New York Vista 1 computer. And now that we're on the New York Vista 1 client, I want to go ahead and click Start and Command Prompt. And what I want to do next is ipconfig/all, because what I want to make sure that we review, make sure nothing has changed, is that our DNS servers are listed as 192.168.10.201 and 202. Our Win server is listed as 100. The next thing I want to do is I'm going to type in an ipconfig/display DNS. This is going to display the local DNS cache for New York Vista 1. And here I have the cache, and let's see what's in this cache. I have a couple of local host entries. I have an entry for New York DC2 being 10.202. Apparently I've communicated with that computer recently. Another local host entry. And okay. Now I want to show you if I were to do a ping New York DC1, I resolve it to newyorkdc1.globalmantics.com. I resolve to the IP address 192.168.10.201. And now I'm going to do an ipconfig display DNS again. By the way, if you're wondering how that came up so easily, I just hit the up arrow. Up and down arrow lets you scroll through commands that you've recently done. So I'm going to hit the up arrow until I get to ipconfig / display DNS. I'll hit enter. And now when I scroll through the list, I still have my local hosts, but now I have an entry for New York DC1 with the IP address that we resolved to. And of course, we still have New York DC2 and our local hosts. Now, the next thing I want to do is type in ipconfig / flush DNS. This is going to clear the cache. Let me go ahead and hit enter. Successfully flushed. Let's go ahead and display the cache again. And you'll notice there is still some entries in the cache. And they're all localhost, localhost, localhost. I'm going to scroll up here. Localhost, localhost. And that's it. Okay, the cache has been cleared other than localhost. Why is that still in the cache? Well, let's go ahead and go back to our host file. So c:\Windows, system32, drivers, etc. Right? That's the folder that we'll find it in. There's our host file. Let's go ahead and open it up with Notepad. And you'll notice there are entries for localhost. That's why they're still in the cache. As long as we're in the host file, let's go ahead and add another entry for 192.168.10.50 demo. We'll even say demo.globomantics.com. All right, so we now have an extra entry in the host file. I'm going to go ahead and close this. Click Save. Close that. Go back to our command prompt window. And without doing anything else, let's do another ipconfig / display DNS. And now, when I go through, you'll notice I didn't do anything else. I still have local hosts, but I also now have entries for demo.globomantics.com resolving to 192.168.10.50. I did not have to connect with that computer. I didn't have to do anything else. As soon as it went into the host file, boom, it's in the cache. Matter of fact, I can tell you that demo.globomantics.com does not exist, and 192.168.10.50 does not exist. Now, before I go any further with this, let me go ahead and minimize my Vista machine, and let me go back over to my New York DC1 DNS server. So we're already in the DNS manager, and in globomantics.com, I'm going to right-click and select to create a new host. This was demonstrated a couple of videos ago in configuring DNS. In here, I'm going to create a record, a new host record for demo.globomantics.com and give it an IP address of 192.168.10. Now, we said .50 in our host file. So we're going to say that the IP address of demo.globomantics.com is actually 192.168.10. I'm going to say .100, even though that's not, there is no machine for demo.globomantics.com. And 10.100 was actually New York member 1, but that's okay. I want to give it a live IP address. Okay, so we're going to say that that machine is now called demo.globomantics.com. I'm going to add the host record. Click OK, because it's been created. Done. You'll see I have a record down here. It says that demo is 10.100. Now that that's done, let's go ahead and minimize our DC1 computer. Go back to Vista 1. And what I'm going to do here is I am going to ping demo. And hit enter and watch what happens. You will notice that it resolves. First of all, it says it's pinging demo.globomantics.com. And that's because we have Vista configured to do the suffix lookup or the automatic suffix addition, since I'm a member of the globomantics.com domain. So demo.globomantics.com resolved to 192.168.10.50, which is not correct. Don't worry about the fact that this is trying to get a reply from .225. That's something built into my network here that you shouldn't be experiencing there. So it is going ahead and resolving to 10.50. This is the only part that we care about. Now, this is where typical troubleshooting or name resolution troubleshooting should come into play. I know as an administrator that demo is not supposed to be 192.168.10.50. It's supposed to be .100. So I need to go through my name resolution process. And step one of that process is to look at the DNS cache. So I'm going to do an ipconfig / display DNS. And I'm going to look, and what I'm going to find is that there is an entry for demo.globalmantics.com, and it is at .50. So I have my answer. Awesome. I know what I need to do. I need to flush that cache. I'm not sure where that bad result came from, but I need to flush that cache. So let's go ahead and do an ipconfig / flush DNS. They might try to go ahead and ping again, only to have it resolved to 50 again, and then they say, oh, well, it's apparently not coming from the cache. It might be coming from some other location. So the wrong step would be to flush the DNS cache again, and then say, let's leave this machine and start looking at DNS servers. That would be the wrong step, because what would happen is this. You go away from your client machine, you go over to your your DNS server, you see an entry for demo, and you say, that's wrong. And then you start looking at other DNS servers, and you start looking at Win servers, and none of them have an entry for .50. And then you start scratching your head, and you go nuts. You say, well, why the heck does it keep showing up in the cache? Well, the right answer is to remember that you check the cache. And then a big part of the reason why a lot of books will separate this into two different steps is because administrators will then remember step 2 is to look to the host file. So we go back here and go to our host file. And I'm going to go ahead and jump to a recent location here. Open up the host file. And they go, aha, there's our problem. So I'm going to clear that entry out, close the host file, save the changes, go back to my command prompt. Just to be sure, what I'm going to do is I'm going to flush my DNS cache one more time. I'm going to display my DNS cache and scroll through, and you'll see here there is no entry for demo anymore. So now I'm going to go ahead and ping demo. And you'll notice it not only resolves the 10.100, but I'm also getting a response to demonstrate that I've successfully connected to that machine. Now, where is it getting that IP address from? Well, it's not getting it from its local cache, as we saw a moment ago. It's not getting it from the host file. So the next step would be it's getting it from its DNS server. And sure enough, New York DC1, the DNS server that this particular client has been configured to use, has an entry pointing demo.globalmantics.com to 192.168.10.100. And the only other thing that I'd like to show you is if I were to ping demo again, it will resolve correctly again. But now if I wanted to start from scratch and say, where am I getting that from? Well, if I display the DNS cache, you will notice there is an entry. Let me scroll up here. There it is, for demo.globalmantics.com being at 192.168.10.100. And the reason this time that it's in the cache is not because of the host file, but because I looked it up recently, and that's why it's there. All right, so that's how we troubleshoot name resolution problems. Now let's talk a little bit about integrating host and NetBIOS name lookup. First bullet point I have here is implementing something called WINS lookup on a DNS server. This is where a DNS server can query a WINS server for a NetBIOS name similar to a host name if it is unable to resolve the host name for a client from its own database. Now, this is something that we saw just a few moments ago that a client will do on its own. A client, when trying to look up a host name, will go through the NetBIOS name resolution process if it's unable to resolve the host name through the host name resolution process. Well, this is where we can have the DNS server kind of do it on behalf of the client. Now the client can simply be configured with the DNS server and nothing else. And if the DNS server doesn't have an answer, it will then go out to a WINS server to try to find a matching NetBIOS name. The next bullet point I have here is implementing the global names zone. Now, this is something that is brand new to Server 2008. And the global names zone was put in place to assist with the potential retirement of WINS servers. WINS servers, as I said earlier, are something that was real prominent back in the days of Windows NT,
a decade ago. And little by little, we're trying to work them out of today's networks. And the global name zone has taken a huge step in that direction. Now, the global name zone provides single name resolution similar to how WINS did it. And I'm going to emphasize on similar. And right here, where you talk about the global name zone eliminating the need to implement WINS servers, but if you're doing it exclusively for the purpose of supporting single label names for centralized servers. What this all means is that the global names zone is assisting with the retirement of WINS, but does not replace WINS altogether. The global names zone is not going to resolve NetBIOS names. What it's going to do is provide for single name resolution, which was very similar to how WINS did it or how NetBIOS names did it. Now, let me give you an example to try to clear this up. In this example, I want to take a look at the Global Mantics network. Now, we've already known from our past scenario about the globalmantics.com, na.globalmantics.com, and asia.globalmantics.com domains. But to further explain this, we're going to say that Global Mantics has gotten together with TrainSignal. They've merged, and likewise, the TrainSignal.com namespace has been added to the Global Mantics network. So we have TrainSignal.com, and a.transsignal.com, and Europe.transsignal.com. Now that we have all of this namespace, let's use an example to where we say let's say there's a server. We'll just call it server 1 because that's a name we've been using, and it's in the globalmantics.com domain. That's where it physically resides. This server needs to be accessed by everybody within the entire Global Mantics network. And we want users to be able to access it by just simply entering the name server 1. So let's go down here to the North America.transignal.com domain, and let's say there's a client down here that wants to access that server. This client puts in server 1 and wants to resolve to that particular server. Well, what's going to happen by default is this particular client is going to be configured to look to its primary DNS suffix, na.transsignal.com, and append that to the name because that's the domain that it's a member of. So this client is going to attempt to look up server1.na.transsignal.com. It's not going to get a result, though, because there is no server 1 in that particular domain. Then it will be configured to look to the parent DNS namespace, which is transsignal.com. So it's going to go ahead and append that to server 1 to get server1.transsignal.com. Guess what? Again, no response because server 1 doesn't exist there. The client is now going to go ahead and give a response saying there's no such server, you're out of luck. Now there's a couple solutions for this. One would be to manually go into the client machine and add the globalmantics.com and the na.globalmantics.com and the asia.globalmantics.com suffixes in the DNS suffix search order. But that would be a nuisance because you'd have to go to every single client throughout the entire network, and every time there's a change, you'd have to go back to every single client. So that's just not realistic at all. What is a little more realistic is to use something called group policy. Group policy is something that can be used through Active Directory to go ahead and push down this configuration to all of the clients. So we could create a group policy setting that makes it that all our clients have the DNS suffix search order for all 6 of our domains in the Global Mantics network. Now this would work because now this client would look at na.transsignal.com, wouldn't work, look transsignal.com wouldn't work, would then probably next in line in the search order would probably be to the globalmantics.com domain. It would now search server1.globalmantics.com and it would work because that server does exist. But even that is not necessarily the best solution because let's say Global Mantics now merges with another company and my drawing is a little sloppy here, but let's say we have another domain and it has a new name and it has a whole structure built in, and every time you add a domain to the Global Mantics network, we would have to now make a change to that group policy setting. So the global names zone can help eliminate that. The global names zone, we would create a global name zone which would be used and replicated throughout the entire forest, so the entire Global Mantics network, so all DNS servers would know about it. And in this global name zone, we would have what's called aliases. And there would be an alias for server 1. And that alias would say, anybody looking for server 1, the fully qualified domain name is server1.globalmantics.com. Point them to that particular location. Why don't we go ahead and take a look at our DNS server, because I'm sure you're thoroughly confused by this point, and see how both WINS lookup and the global name zone works. For this demonstration, I'm going to go ahead and take us back into New York DC1, which is our DNS server. So let me take us back there now. Here we're already in the DNS manager. Let me go ahead and expand New York DC1, expand forward lookup zones, and here we have our globalmantics.com domain. So let's go ahead and right click and go to its properties. And right here you'll notice there is a WINS tab. I'm going to click on the WINS tab, and this is where you can allow this DNS server, when trying to resolve for the globalmantics.com domain, to use WINS forward lookup. I'm going to check the box. What this does is this makes it that this DNS server will now go out to a WINS server, which you specify down here by giving the IP address of a WINS server, and click Add, to look for a NetBIOS name similar to the host name that the client is querying it with. Now right here is a checkbox that says do not replicate this record. If we do not check the box, and it's not checked by default, then what the DNS server is going to do is, client goes to DNS server. DNS server looks in its database, doesn't find the host. It goes out to the WINS server and says, hey, WINS server, do you know who this is? WINS server gives back a positive response and says, yes, I do. This DNS server will go ahead and replicate the record into its own database so that anytime in the future another client makes that same request, it doesn't have to go back out to the WINS server. If we don't want our DNS database to become cluttered with these records, then we check the box to say do not replicate this record. And that's how WINS lookup works. Now again, this is something that you will very possibly never do because WINS is quickly becoming a thing of the past. But just in case you are still running WINS servers, that is something that you can do with your DNS server. So let me go ahead. I'm going to actually click cancel to get rid of all of this. Now what we want to do is go ahead and implement the global names zone. Now in order to do this, the first thing you need to do is you need to enable the global names support functionality on your DNS server. So how do we do this? Well, I'm going to go ahead and click start and open up a command prompt. From the command prompt, what you want to do is type DNS command. Now this is a command line utility for the management of your DNS server, which we spoke about in the last video. You then need to put in the server name, so New York DC1 2K8 space, and now I have to put in /config, saying I want to configure the server, / enable global names support space 1. In other words, we are modifying a registry setting on this particular computer, on this particular DNS server. And there is a setting called enable global, and actually I misspelled it, so let me go ahead and fix that. It's global with an A if you were following along. Enable global name support is a registry entry, and we're going to change that to 1 because by default it's set to 0, meaning we don't support it. So I'm going to go ahead and hit enter. And you'll see here that it says that the registry property was successfully reset. The command was completed successfully. So now we have global name support on this particular DNS server. So let's go ahead and close this. Go back to our DNS manager. In the DNS manager, what we're going to do is go ahead and right click on our server and select New Zone. And click Next. We're going to make it a primary zone. Because we're a domain controller, we can make it Active Directory integrated. Again, if you haven't looked at the previous couple of videos, this was all explained if you're not familiar with this. So I'm going to go ahead and click Next. Typically what we want to do is we're going to go ahead and we are going to replicate this to all DNS servers in the entire forest. We want everybody to know about this zone. So next, it's going to be a forward lookup zone. Next. By the way, let me go back a second. This question right here for forward lookup zone, I'll show you how you can eliminate this question in just a moment. I'm going to click Next. The name of the zone needs to be global names. So that's the actual, go figure. The global name zone is actually named global names. Next. And we do not in any way, shape, or form want to allow dynamic updates to this particular zone. This is for centralized servers only. This is for things that you are going to manually, as an administrator, put an entry in there. Click Next and Finish. And I now have a global names zone. Now, I told you I was going to tell you how you can get rid of the question for the forward lookup. Well, if instead of right-clicking on the server, if I were to right-click on forward lookup zones, new zone, it's going to know that it's a forward lookup zone. So it's going to take me right into what type of zone, replication scope, and then just right to the name. Either way is fully acceptable. So let me go ahead and cancel out of there. Here I have my global names zone. The next thing I need to do, once I have a global name zone, is I need to create an alias. I need to create an alias for each of these computers that we're talking about. So I'm going to right click and select New Alias, or technically it's a CNAME. And then I'm going to go ahead and give it a name, and we'll just call it, we'll just go ahead and go with Server 1. And Server 1, we're going to say is an alias that points to, and watch this, I'm going to point it to a real host that we have on our network, which is going to be New York-member, or just mem1 2k8.globalmantics.com. Okay, so that is a fully qualified name of an actual server on our network. And I'm going to click OK. So here we have a Server 1 alias pointing to that fully qualified domain name to New York Member 1. Now that we have that in place, let me go ahead and minimize New York DC1, and let's go back to our Vista client. On our Vista client, and let me go ahead and clear that other stuff that we were looking at before out of there. I'm going to go ahead and say that I want to ping Server 1. A nice simple name. Hit Enter. And you will see here that it resolved to New York Member 1 2k8.globalmantics.com. It resolved it to an IP address, and it got successful replies from that IP address because New York Member 1 does exist on our network. I will tell you that I can open up any client through the entire GlobalMantics forest, and as long as it is looking at a DNS server that has a copy of the global names zone, it will know that alias, and that is what its purpose is. All right, so that is how WINS lookup, or within a DNS server anyway, so DNS WINS lookup and the global names zone function. Let's go ahead and review what we've covered in this video. In this video, we took a look at the difference between host names and NetBIOS names. We saw that host names are more typically used these days because of their support for internet capabilities, and that NetBIOS names were heavily supported back in the 90s because of their simplicity, but unfortunately have no support for internet capabilities, so are pretty much a thing of the past. We took a look at host files and LM host files and saw that although they are simple text documents, it would not be simple to manage our network, having to manage one on every single computer in the network. So we then moved along to look at DNS and WINS servers, which are a more dynamic way of resolving host and NetBIOS names. We looked at our client configuration, including not only the DNS server list, but a DNS suffix search order, and then our Win server list. We looked at the name resolution process as a whole and saw how to therefore troubleshoot name resolution problems. We then looked at how to implement Win's lookup on a DNS server, and also the implementation of the global names zone to help with the elimination of our Win server or the need for our Win servers on our network. I hope you enjoyed this video, and I look forward to seeing you in the next one.